Hello, I welcome you all to this another interesting screencast. The problem reads: the square threaded screw has a mean diameter of 20 millimeters and a lead of 4 millimeters. If the weight of the plate A is 5 pounds, determine the smallest coefficient of static friction between the screw and the plate so that the plate does not travel down the screw when the plate is suspended as shown. Right, this problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to determine the smallest coefficient of static friction between the screw and the plate so that the plate does not travel down the screw when the plate is suspended as shown. Right. So for this plate not to travel down, then it has to experience what is called self-locking. So we know that self-locking screw takes place when this condition is met, which is phi should be greater or equal to theta, okay, where tan phi is equal to the coefficient of static friction and tan theta is equal to the lead angle, which is equal to the lead itself, L, divided by the length or the circumference, which is 2 pi r. Okay, right. So what we'll do now, we'll need to draw our model so that we just apply those particular rules. So before we do so, let's calculate quickly our lead angle. Okay, there we go. Just move it somewhere here. So we know that D is equal to 20 millimeters. Therefore, R will be 10 millimeters, which is the radius of the screw. Okay, and then we have the lead L, which is 4 millimeters. Okay, so we have this length here. This is unwinding a thread of 1 revolution. We unwind it, so this is how it appears. Okay, there we go. So with this we can calculate what is called the lead angle, and we know that tan theta is equal to L divided by 2 pi r, and therefore tan theta will be equal to L, we said is 4 divided by 2 pi times r, which is 10. Okay, therefore tan theta will be equal to 1 divided by 5 pi. Okay, which eventually is equal to 0.06366, right? Sorry. Okay, so we found what tan theta is. Then we already have said that for the self-locking to occur, phi must be either greater or equal to theta. Okay, but of course we are going to use the condition phi equal to theta so that we find the minimum value of phi. Okay, so with the minimum value of phi, then we have the minimum coefficient. Alright, so let's draw the model for the the screw. So we have the threads there. Okay, or the screw itself. Alright, there we go. We have the screw. Alright, and we have a load, which is just the weight. I mean the weight of the plate, which is 5 pounds. Okay, and there we go. We have theta there, the lead angle. Okay, we do expect because we are not applying any force here. We are just saying the weight itself should equilibrate itself with the friction. So we are going to have a component, the friction there, which is F, and the normal force like so. Alright, so for theta, or for phi to be equal to theta, then we expect the resultant to just be vertical, right? Okay, therefore we expect theta here to be equal to phi to be equal to theta. Okay, right. So once we have this condition, we also know that therefore our resultant, okay, if we are to take summation of forces in the y, we only have one equation, summation of forces in the y equal to 0. Therefore r minus w, which is 5, equal to 0. Therefore r is equal to 5 pounds. Okay, we know that. Well and good. Let's continue. So we also know that tan theta, okay, tan phi itself is supposed to be equal to tan tan theta, and we know what tan theta is. We just calculated it there. It is 0.064, right? And we know that therefore tan theta is equal to 0.064, and tan theta is equal to mu. Therefore the minimum mu is equal to 0.064. That's rounding it off. Okay, so this is about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Give me a thumbs up. Bye bye, and see you in my next screencast.